using a motor. There are this. I'll suspend a block. There's a gear B. Now the teeth. There's a rough teeth. The teeth should be properly, all the teeth should be identical and it should exactly fit into the other gear. I don't have time, so I'm just scribbling it. Huh? Okay, come for this. No, there's a gear A. It is being rotated. RB. So this is having angular acceleration alpha. Then how do the gear B will rotate? So the velocity of this point should be equal to velocity of this point, because the gear A will rotate clockwise. Then the linear velocity at this point will be downward. Then the teeth, they'll come in contact. So this gear A, when it's rotating open, it will push the teeth of the gear B, and the gear B will have linear velocity in this direction. So what is the basic idea here? The velocity of linear velocity of this point should be equal to linear velocity of this point. So what is V1? V1 should be equal to RA omega A. What about V2? Should be equal to RB omega B. So therefore the angular velocity of this gear should be in this direction. The angular velocity of this gear B is in this direction, means then what should be the angular velocity of this point P? Linear velocity of this point P should be upward. Got it? So what is VP? VP should be equal to RP into omega A. Symbols V2, V1 equal to RA omega, V2 equal to RB. Oh, yeah, fine. What is VP? VP equal to RP into omega A. Omega B it is. Then there's a string inextensible. So the velocity of block C must be equal to velocity of point. Any reason the string is inextensible. So therefore VC should be equal to VP. Some is asked something related to this chord is wrapped. There's a chord. Chord is inextensible from P to the block C should be inextensible. So the velocity of point P, the velocity of block C should be equal to linear velocity of point P, not any other velocity, because this part of the string is inextensible. So we show like this here. I'll put one more last one. If there's a length of the rod, x equal to 0, x equal to L, it is kept on horizontal surface. A force which will act like this.